According to the 1999 and 2002 National Electrical Codes, Section 250.120 bone grounding electrode conductor material shall be of copper, aluminum, copper-clad aluminum, iron, or steel. Other materials such as stainless steel, lead, or zinc shall not be used. Section 250.120b3 addresses underground installations, stating that grounding electrode conductors shall be installed in a trench or otherwise covered with earth fill or other protective covering. Where necessary to enter a building or structure, the grounding electrode conductor shall be protected from physical damage. Section 250.120c discusses flexible conductors. Where flexible conductors are used to connect the grounding electrode to the system grounded conductor at the service, such conductors shall be stranded, insulated, copper conductors not smaller than 6 American wire gauge. The insulation shall be listed for direct burial unless the conductor is installed in a raceway or otherwise protected from physical damage according to the 1999 NEC. In the 2002 NEC, Section 250.120c adds that where flexible conductors are used to connect the grounding electrode to the system grounded conductor at the service, such conductors shall be stranded, insulated, copper conductors not smaller than 6 American wire gauge. The insulation shall be rated for direct burial in accordance with Table 310.10 where the conductor is installed underground. Where installed in a raceway, the insulation shall be rated for the location of the raceway. Based on these code sections, flexible grounding electrode conductors are permitted for use, but they must be stranded, insulated, copper conductors not smaller than 6 American wire gauge. The insulation must be listed for direct burial if the conductor is installed underground. However, flexible grounding electrode conductors are not permitted to be used in underground installations. The foreman's instruction to not use any flex in the grounding electrode for the transformer is correct according to the NEC. One cannot use flexible grounding electrode conductors in underground installations. Regarding the use of flex-covered ground for residential applications, it is permitted for use in residential applications for the following reasons. Firstly, residential grounding electrodes are typically not buried underground. Secondly, flex-covered ground is insulated and protected from physical damage. Thirdly, flex-covered ground is not used to connect the grounding electrode to the system-grounded conductor at the service. In summary, the NEC allows flexible grounding electrode conductors under specific conditions, primarily when they are not buried underground and meet the requirements for size, insulation, and material. The allowance of flex-covered ground in residential settings is due to the typical installation methods and the specific application of these conductors. Always consult the latest version of the NEC and local amendments for the most accurate and up-to-date information on electrical installations and grounding requirements.